In this lesson, we are going to have a look at the area of a triangle. Now, traditionally, the formula that we have been using since probably about grade 6-ish is area equals half times the base length times the perpendicular height, right? So if we have the perpendicular height and the base length, that's the formula we're going to use, half times base times height. But having said that, what happens in situations when we actually don't have the perpendicular height of the triangle? Right? That's what we're going to look at in today's lesson. The first formula I want to focus on is when we are given two side lengths, right? When we're given two side lengths and the angle in between them, or the included angle, right? So the formula we're going to use to find the area of the triangle is equal to half times the product of the two sides times the sine of the angle between them, right? So that's the formula we are going to use to find the area of the triangle. Right, so in this question here, right, find the area of the triangle ABC. We have the two sides, and we also have the angle in between the two sides, right? So the formula basically represents half times the product of the two sides, so 7.2 times 6.5 times by the sine of the angle in between them, which is 140 degrees. Right, so we put that in our CAS calculators, or any calculator as such. Right, so half times, got 7.2 times 6.5 times the sine of the angle in between, which is 140 degrees, and the area of the triangle, corrected 2 decimal places, is 15.04 centimeter squared. Alright, that's the first one I wanted to look at today. The second formula I want to look at today is what we call as the Heron's formula, right? And the place when we need to use the Heron's formula to find the area of the triangle is if we don't have the perpendicular height or any angle given to us, right? So the circumstance we're going to use the Heron's formula is when we're given the length of all the three sides of the triangle. Right, and the Heron's formula is given by the square root of s times s minus a times s minus b times s minus c, where s is what we call as the semi-perimeter of the triangle, right, which is basically the perimeter divided by 2, right? So let's go into the example here, right? Find the area of the triangle with sides 6 centimeters, 4 centimeters, and 4 centimeters. So two sides of 4 centimeters, and then the third side being the 6 centimeter side. Right? So we've been given the length of all the three sides. Right? The first step in finding the area of the triangle using the Heron's formula is to work out the semi-perimeter. So 6 plus 4 plus 4, which gives us 14, and 14 divided by 2 gives us 7. And that's the length of the semi-perimeter, right? Or half the size of the perimeter. Right? Now that we've worked out the value for s, we're going to use the formula. So area equals the square root of s, which is 7 times 7 minus a, so for the first side, times 7 minus b, the second side, and then 7 minus c, the third side, right? Which basically is nothing but 7 times 1 times 3 times 3, right? So if we put that in our calculators, the square root of, right, 7 times 1 times 3 times 3, and control enter, giving us in the form of a decimal, right, the area of the triangle is equal to 7.94 centimeter squared, correct to 2 decimal places as they have requested in the question, right? It's really critical that we enter the units as well, given that they've given us the units as centimeters in the question. Right, so those are the two formulas that we can use if we can't use the half times base times height, right? But if we are given the perpendicular height and the base length, go ahead and use the known formula we've learned since grade 6. Right, that comes to the end of this lesson. Thank you for listening, guys, and have a wonderful day.